Okay, so now we're going to answer our first question raised at the end of the previous video. When we have multiple regression models, how to pick one that we believe is the best. So let's start with the very first model, okay, when we only have size as the variable. When we are thinking about this relationship, when we are thinking about this particular linear relation, we want to ask how good it is or how precise it is. Okay, now let's try to answer this question. Suppose I have a linear model, linear relationship, and then when we want to evaluate its quality, we're going to have a benchmark. That benchmark is what may we do if we don't have any model. Okay? If we don't have any model, then when someone asks you about given a house, how would you predict its price? Then the most naive way would be to simply use the simple outcome, the simple mean, as the predictor, right? In any case, we can always simply use those simple mean as the indicator, as the predictor. Then that's going to be somewhat very stupid, right? We don't really consider any relationship between price and size. We ignore all other information. So that's going to be our benchmark. We have something we believe that is smart, and we have something that we believe is very stupid. We want to know how good, how better we are with that so-called smart model. So some variables that we define. First, if we only have the simple mean, okay? When we have no model, the sum of squared total errors is called SST and is the sum of the square of all the deviation with respect to the simple mean. If we have our regression model, then that simple mean is going to become simple, and I should say the estimate of our regression model. Okay, yi is going to be compared with yi hat, and then that's the something we are familiar with. This is SSE. Okay, the sum of squared errors, and then we define something called R squared as the proportion of total errors that is explained by the regression model. Okay, it's defined as 1 minus SSE over SST. SST is the total error. Suppose we have so many errors, okay, then for some of them, they can be explained by SSE, okay, and then if our SSE is here and the SST is here, then that means our model can eliminate this amount of errors. Then this would be the power of our model, and then that's related to R squared. Okay, R squared is the proportion of this proportion. So it's not very hard for you to answer why R squared would always be within 0 and 1. Okay, try to think about it. It's not very hard. So starting from now, please memorize what's the physical meaning of R squared. R squared is how our model is better than no model. Okay, R squared is how our model can eliminate estimation errors. So R squared definitely has its formula, so it can be simply calculated by reading reports. Suppose we use R to do linear regression. Then now we need one more step to read R squared. we're going to call this function lm, get its output, store it to any variable, or let's call it fit or f or whatever you like. Then we call the function summary with respect to fit. When we summarize fit, we will see a detailed report for the regression analysis. And at the bottom, we would see something called multiple r squared. Okay, this particular number is our r squared. So in that problem, in this particular model, the r squared would be 0.53. And that means around 58% of a house price is determined by its house size. Okay? If we can control house size, then we can control around 53% of house price. We definitely know house size is not the only indicator, not the only factor that affect house price. But for this r squared, we believe that it controls or it determines around 50% of the house price. And that means all other factors together only counts for 47%. Okay, so house size is really significant in explaining house price. In Excel, it's also very similar. When you finish that regression analysis, you see a large report, and for that report, you have this number, r squared. Again, it's around 53%. One note I want to tell you is that suppose there is only one independent variable, then you know there is x and there is y. You can always calculate their correlation coefficient, small r. If you square that r, it is going to be your r squared. Okay? So you see capital R squared equals small r squared, and you probably get confused at the beginning. Keep in mind that r squared itself is a number. We don't really care about capital R. Okay, we don't really care about it. We care about r squared. Itself is a number. Okay, itself is a number. But here, small r is the correlation coefficient. Okay, so mathematically they happen to be identical. That's of course because of their definitions. Okay, but if you have more than two variables as independent variables, then you can say nothing about this relationship. R squared is not going to be related to correlation coefficient in any way. Okay, so if we want, we may build three regression models, one with only price as the independent variable, one with only bedroom, and one with price and bedroom. We're going to see that first, using price only is better than using the number of bedrooms. Okay, if we only talk about bedrooms, then it only counts for around 29% of the outcome. It's not something that is really meaningful. But for price, the R squared is higher. So using price should be a better idea than using bedrooms. But if you combine both of them, obviously we do not expect the R squared to be the sum of these two. Okay, because these two somewhat may be conflicting with each other. And eventually we see adding bedrooms into price only give you around 2% more increase in R squared. Okay, so that means bedrooms, that's another way to say that bedrooms are really not so useful in this particular model. Okay, but then you may still think at least 55 is greater than 53. Using two variables is still more precise than using only one variables. Here, this is very dangerous. Okay, in general, adding more variable always increase R squared. Okay, this is something that you definitely need to keep in mind. Adding more variables always increase R squared. Why? Suppose originally you only have one variable. Now you add another variable. In the worst case, you can simply set that coefficient to 0. Then you go back to your old model. So that means the model with one more variable cannot be worse than the previous model. Okay? So almost always you see R squared to be increased when you add more variables into an existing model. And actually some variables may be meaningless. Okay? So at least you know one thing. When you do multiple regression, do not add as many variables as you have into a model. You're going to have a very high R squared, but your model can just be meaningless. Okay, can just be meaningless. So we need to perform somewhat a fair comparison, and the idea would be simple. If you need a lot of variables to have a slightly higher R squared, then it's not going to be better than using fewer variables to get roughly the same amount of R squared. Okay, here, one single variable counts for 53% of price. Oh, sorry, I made a mistake. This is size. Okay, size. When you have one variable, it counts for 53%. When you have two variables together, they only count around 55. And that means your bedroom variable is actually destroying the impact of the size variable. So to really compare these two models, we need to use the so-called adjusted R squared, like this. We define a quantity called adjusted R squared as a formula, as a function of R squared. And basically it depends on the number of independent variables you use. If you use more independent variables, then you are going to get discounted more. Okay, and this is independent variables. Okay, so if we apply this formula, then we can get those. Okay, these are again sizes. We can get their R's, adjusted R squares. And now, as we expect, using size is the best. Is R squared is actually better than or higher than using both sizes and bedrooms. Okay, so in this particular example, the best model we have is to use price only. So adjusted R squared is your main indicator for the efficiency or quality of a regression model. If you go back to check your regression reports, you always see adjusted R squared listed close to R squared. Okay, you don't need to calculate them by yourself. You have that software. Thank you.